So today what we're going to do is we're going to work on this investigation, right? The investigation is their first foray into a thing called trigonometry. So here's what we're going to do. We're going to measure this triangle from the bottom left angle. The bottom left angle here is about 30 degrees, right? When you're measuring, what I want you to do is I want you to measure everything in terms of millimeters. So when I ask you to measure, I ask you to measure the length of the hypotenuse of each triangle and the length of the opposite to the angle for each triangle, which we will label O, and the hypotenuse, which measures from here to here for this triangle, from here to here for this triangle, and for here to here for this big triangle here. Okay? And that's what we want. You'll also do the same for the side that is adjacent to our triangle. Now, I also want you to calculate the adjacent, so we'll call this little a, and little a, and a for this one goes all the way back to the beginning in millimeters, and this one goes all the way back to the beginning in this one. And what I want you to do is I need you to take all that information and put it into the information for the small triangle, medium, and large triangle. The sides will be H, O, and A, H, O, and A, H, O, and A. Okay. Now, for your observations, I need you to calculate side O over H here. The same for this one. Calculate O over H. And calculate O over H. So remember, I want you to fill in all of the lengths in millimeters for all the different triangles, for the small, the medium, and the large triangle. Then what I want you to do is I want you to make sure that you come up with an observation that talks about the triangles and whether they are similar or not. And then finally, you need to tell me if these side lengths are proportional. You need to tell me if these things are proportional or not. So just pause here, work through the problems, and then you can finish up the rest of the video. You'll definitely need a ruler for this. First of all, for trigonometry, we need a right-angled triangle. Now we know that this from here from the corner to the opposite side is called the hypotenuse, so we will label that H. If we have an angle that we're always referencing, the side that is beside it is called the A value, or the adjacent, and the side opposite to it is called the opposite. And just like I said, H was for the hypotenuse, O was for the opposite, and A was for the adjacent side. So think of it as the side length beside the angle. Pause the video here and copy this note. Okay, so now let's talk about the three major trigonometric ratios. Sine gives us the equation sine of theta is equal to the opposite over hypotenuse. Cosine is given by cos of theta is equal to adjacent over hypotenuse. Tangent is tan of theta, which equals to O over A. So we have a saying for us to remember these different things. Sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. And tan is equal to opposite over adjacent. We pronounce this so, ka, toa, in order to remember our ratios. Pause the video and copy this note. Okay, so let's go to using your calculator for this. You'll need to have your calculator in scientific mode. I would prefer that all of you have your own calculators. You'll need it for the rest of the semester. So, when we're finding a trig ratio, when you use your calculator, you type sine of 30 degrees. And when you punch in sine of 30, you get an answer, maybe 0.5. And when you punch in cos of 60 degrees, you're going to get 0.5. When you type tan of something like 73 degrees, you're going to get something that just goes on forever. But what I need is at least 4 decimal places. So 3.2709. This part is what is most important for our calculations. So if I ever ask you for, say, sine of 30 degrees, you're going to get 0.5. But what I want you to do is I want you to add 3 more decimal places so that we have 4 decimal places for accuracy. This is for accuracy in calculations. Now, when we're finding an angle, this case, you actually have the ratio. Okay, so for example, if I have the following, cosine of theta is equal to 0.6921. On your calculator, in order to find theta, we're going to have to do cos inverse of 0.6921. And on your calculator, you're literally just going to have to do this. Shift, cos, and then the number, 0.6921. And then that will give us the actual angle that we were looking for, 46.2 degrees. And that's it. So if I had sine, so this was example 1, here's example 2. If I had sine of theta is equal to 0.2145, we write on our sheet sine inverse of 0.2145, and we do exactly what we did here on our calculator, except this time we do second function, or shift, cosine, da da da. So on some calculators you have second sine of 0.2145, and then that will give you our answer of theta is equal to 12.38 degrees. And we're done. Your homework is textbook, page 71, number 1 and 2.